Assalamu alaikum students, it is our lecture number 5, Fundamental Troubleshooting Procedures. It is the continuity of our previous lecture and it is going to be a short one. In this lecture we will cover grounding symbols, temperature sensitive intermittent problems, what corrective actions can be taken, and in which situations we should avoid repairs, and some general guidelines at the end. Okay, let us start with earth ground. Earth ground means sending current directly into the ground. Ground or earth is considered as a huge neutral sink which is very close to 0 volt of potential, or it is also called as ground potential or just the ground. It provides a low potential path for the current to flow, and the current will follow that low potential path and go into the ground and diffuse there without causing any damage which it would have otherwise caused. So according to National Electrical Code, that by definition earth ground is the one in which this type of conducting rod or conducting wire is driven deep into the earth, and this depth should be at least 8 feet into the ground. Then according to the standard definition it should be considered as earth ground. Okay, so there are different sources which can cause such type of currents, which can cause damage to the structures and to human lives as well. One of them, the natural biggest reason is the lightning during thunderstorms. If it strikes a building, it can cause immense uh, destruction and damages in there, not only to the structures but also to the human lives and other valuable items in there. So that, and the building is also grounded. The building is grounded using an lightning rod on the top of the building, which collects all the current from the lightning strike, and through the conductor it dumps that huge amount of current into the ground, which there safely goes and diffuses into it without causing any damage. So the other source of unwanted currents which may occur because of anything due to malfunction of devices, short circuiting, or anything. So for safety reasons, all those electrical appliances in a building are connected to a ground plate. Like in this oscilloscope, the grounding circuits are the BNC, the outer shell of the BNC connectors are grounds are considered as ground lead terminals, or ground lead terminals, and this one is also for the probe. This is also ground. So these grounds from various uh, electrical appliances or wherever is necessary, those are connected to uh, copper plate or this copper strip, which is provided in the building at several locations wherever conveniently necessary. So those are it provides electrical connections with, and we can connect all the electrical appliances directly on this copper strip, and with this copper strip is then connected with this rod or this type of wire, which eventually grounds the current, and this is how grounding of appliances is performed. Okay, this was oscilloscope is just an example. If you look at the three-pronged plug, the top prong means one of the three, the biggest one is also earth or the ground connection with that prong. So that is also considered as a grounding connection. So like this one, you can see in the labs or in the buildings, certain means in the portions wherever they have designed it to be. So this is for the safety purposes, but it does not always mean the same. So we should when electronics is concerned, it's not always sending current to the ground, but it may mean different things. Also it depends on the context we are talking about and the type of circuit we are dealing with. Okay, there are different types of grounding symbols as we can see. So in these are the main ones: chassis ground, earth ground, and signal ground. The chassis ground symbol looks like a leaf sweeper, and this is the earth ground symbol in which three lines are stacked with a vertical line on the top. And then there's a signal ground. This is different from the other two. So the earth ground symbol has two uh, sub symbols, you can say. This is the general one, and then this one with the semicircle on the top, inverted semicircle, it is noiseless earth. And the one with a full circle enclosing the earth symbol is called as protective earth. And the one that with one vertical line and a downward pointing triangle is the signal ground. Okay, chassis ground, it is a ground collection point, means that several components which needs to be grounded, their connections are connected at the chassis, and then it follows the flow of the ground circuit then. So these are the ground traces on the circuit boards, and these are the ground leads on the motors and solenoids, means the wires which are coming out of the motors and solenoids. And then the case of the equipment, if the case is made of metal, that can act as a ground collection point as well. Okay, and it actually prevents current from circulating into the chassis, okay, which can be caused by even the static charges, and can also cause a mild shock upon touching that, if there is an accumulation of that. So in the schematic diagram, you will see there can be components inside it, and this thick lining around them is the grounding, the ground trace. This is the ground trace of a metal, for mostly most likely the copper. And these small lines are the collections, are the connections, and then whichever component needs to be grounded is grounded through this thick ground trace surrounding it. So this one is connected with this thick ground trace is connected with the metal shield around the power supply, which is then connected to the third prong of the wall socket, which is connected to the earth or grounding of the building actually. So in this way, all these small components in on a PCB uh, connected to the actual earth or ground of the building through this trace, ground trace, and this chassis, this metal shield. We can call this trace, this setup as a um, uh, chassis chassis ground. Okay, in the next circuit diagram, on the photograph of a circuit, we can see there is a PCB where this is supposed to be all these components inside. This circuit is drawn, and this thick tracing on surrounding of all these components is the ground trace actually. Okay, this is the ground collection point also for all the components. Okay, in the next one, there's another PCB. It's a different type of tracing, but again it is this thick, and then it is also running in the center also. So these are two sections of the circuits drawn, one on one side and on the other side, and for them this ground trace is provided for all the components which require to be grounded. Another example, this is a larger one. It has many different sections, and all these sections have a ground trace around it. Okay, you can see this one and this one. All the thick lines which are in the form of rectangles are ground traces in all of these circuit sections. So whichever component provides, whichever component needs a grounding connection, that can be connected to these ground traces. And this is a ground testing pin. It is provided on the circuit board also, because it's not always convenient to test every component because the components are so densely packed and sometimes covered with a shielding. So grounding point is ground testing pin is provided separately on the circuit board at a convenient location where the testing can be performed. And this in this particular figure, this is a chassis ground in which the body, this is the metallic housing of or casing of an equipment that has a ground connection. If you see that, there is a protective ground symbol also. So this is a chassis ground. Actually, this power plug is connected with uh, the body or casing of the component, and this symbol indicates that this connector is going to ground. Okay, now there is another type of grounding which is called as logic ground. Logic ground is different. It is not the zero voltage type of ground. It is a different one. It is a slightly different potential than the chassis ground. Chassis ground is eventually going to the ground circuit, but this one is different. So it is slightly different potential than the chassis ground. Digital logic ground is the reference terminal of the power supply for the digital logic. Okay, for most cases it is simply the negative terminal of the power supply. Like in this case, we can see this is the power plug, this is the power supply, this is metal shielding like in the example before. This is the chassis ground. You can see that it's written there, and these are the components. You can consider these are the ICs. So this is the on the top is the positive 5 volts, and the bottom connections are going to the negative terminal. So this negative part is the logic ground. This is not the chassis ground or earth ground. This is the logic ground, which has a potential. Is not 0 volt potential. It is the negative terminal of the battery or the power supply. Okay, this the other type. The okay, this type of grounding is different from the ones that we studied in previous slides. In this, our ground signal is as a specific signal is provided, which is considered as our ground. It is a reference point from which other signals are made. What does it mean is, let us see, we have a couple of signals running through. For example, this is one signal, and then there is another signal, this one. These are in our circuit, but what is the level of these? Means on the means how do we measure them? So we measure them by considering a reference. Like this is voltage. So this is, we can consider that this is 0 volt or ground. This is ground. So we can measure from here and from here. This is the level of these signals. But in when signal ground is used, then this one is not done. So this is not the level that we measure. We introduce another signal in there. So we introduce another signal like this signal. I will highlight it with this one. So this is another signal which is introduced into the system. Now the level of these signals which are already running in the circuit will be measured from this signal. This one is signal ground. Okay, so it is important in the type of measurements which are very sensitive and we need very accurate readings. So, it is a clean ground or ground connection without injected noise. Accurate measurements of very small changes in voltage levels, okay, such as those in the medical equipment. We need very small voltage changes to be measured, like in the electrical activity of the heart, or if we are studying brain waves. So very subtle changes in the voltage levels are very important. So in such equipment where these small changes are to be measured accurately, like in the medical equipment, this type of grounding is provided. Okay, now let's move towards the temperature sensitive intermittent problems. So it is observed that uh, if we are it is observed that if we are facing type of problems which are off and on, sometimes they appear and sometimes they do not. So those are called as intermittent problems. So sometimes they happen, sometimes they don't. Most most of the times those intermittent problems are related with temperatures. As the temperature of the device goes up, the problem appears, and as the temperature goes down, the problem disappears again. So such type of problems are, referred to as temperature sensitive intermittent problems. Those are not difficult to locate. So these can occur by raising the temperature of the board. We just use a table lamp or a hair dryer to increase the temperature of the board, and we will see that immediately occurring. The problems immediately appear. So the faulty component that can also be quickly located by combining the act of heating and cooling. We can use a quick spray, pressurized spray of the circuit cooling, that we directly spray on the board and on the components. While the board is hot, the component gets cooled down. So we try many different components. When the faulty component is cooled, the problem re-emerges. Okay, while nothing happens when already fine components are cooled. So when we are cooling down component by component, and as soon as the faulty component is cooled, the same problem will immediately re-emerge, and we will find out that we, we can conclude that this component is actually faulty, which is causing that problem. Sorry. So a quick method by which we can test is by touching and sensing the temperature. So the faulty components tend to be hot. Okay, so we can use the back of our finger to sense the temperature of a component, but it is not highly recommended because there are chances that we may touch the exposed parts of the circuit, or the components which are directly connected with the power supplies. That can be dangerous for us. But if we are careful enough, for the component is bigger in size, we can have this touch and test method for quick testing. Okay, so normally the components which are faulty, they tend to have a bit higher temperature, but not always. We must be careful. It's because some of the components they run at high temperature. That means when they are operating normally, they still are hot, like power transistors. Okay, so we must have a prior knowledge to do this test. So once we have identified the problem, and we have located the faulty components, it's time to take corrective actions. The first step in there is to arrange for replacement parts. While deciding to arrange for replacement parts, we must consider that we should not replace any part unless ultimately or absolutely necessary. Okay, if we try to replace parts unnecessarily, it can cause further damages and failures in the circuit. Okay, so when we have decided to replace certain faulty components, we should prefer buying those from the manufacturer, because those have all the perfect types of electrical and mechanical components for our certain product or the equipment that we are handling. Okay, and in case we want to save time and money also, and also the component that we have to replace is a standard one which can be found from our local vendors. We should proceed with that, buying it from the local vendor, because it will save money and time. And since it is a standard components, all the specifications, mechanical and electrical specifications will be similar, will be identical. So it would not matter if we buy it from the manufacturer or local, and means other than the money and the time that will be affected, that we can consider. If our standard components are faulty, we can easily obtain it from our local vendors and save our precious time and the money. Okay, before we order the replacement parts, the list must be carefully reviewed, because the values, tolerance, rating, and description of the components are very important. If we buy the things which are not compatible, and we do not have the compatible tolerance or the ratings which are required for our specific equipment, those are not going to work and our efforts will be useless. And then the size and shape of the specific component are very important. They affect the performance of the equipment. So if we are going to buy a component that has been modified by the manufacturer, or we are going to buy from somewhere else, not the manufacturer, and the component that we are going to buy looks similar, but it might have a slightly different size and shape, or may also have different lead configurations, which will definitely cause problems when we try to fit that in our okay. And for all the specifications and details about the components in our electronic equipment, we must refer to the service manual. And if we find a discrepancy, that the manual is stating something different, and our and the components which are in our the actual equipment are different, they seem different, then we should refer to a section is called as addenda or addendum. Addendum is a singular and addenda is plural. That is a section which is the new addition to the service manual, which is made after they have made some improvements in the equipment. So the manufacturer might have improved some components in the equipment for better performance, and later on they modify the service manual and they list it under the addenda, heading of addenda or addendum. Like in this case, in this example, Samsung has issued an addendum, user manual addendum, regarding their Android 7.0 software update. So it means that they have made some additions or modifications to their existing user manual. So if in case we see some discrepancies in the listings of the user manual and our actual components in the equipment, we must try to look for the section labeled as addenda or addendum. After acquiring the replacement components, we have to replace the component, right? So for replacing the component, we have to remove the uh, faulty component. So before going into any removal or disassembly of the components, we should disconnect the equipment from the power source for our safety and the safety of the product as well. And then we should use exploded view drawings in the service manual as a guide for disassembling the individual components. Those type of drawings are very useful in assembling and disassembling. Like this one, this is a exploded view diagram of a simple knife. It is not an electronic component, but just for example, this is a simple one. Like it show each and every part which makes up this knife, and the order and the stacking in which they are arranged. It gives a very clear view that how it can be assembled. This is called as an exploded view, like this equipment has been exploded as it is exploded from inside. Is another one. This is an exploded diagram of a drone. As the component increase, the exploded diagram becomes more and more complex because there's so many components in there. So the stack of layers of the components that make up this equipment are arranged in the order of the stacking. And there is another one which you must be very familiar with. This is the 3D exploded diagram of a smartphone, in which all the components are shown. These type of diagrams are mostly shown during the launch ceremonies of the phones and like that. So you must be very familiar with this. So when we are doing disassembly of the components, we must refer to these type of exploded view diagrams, which are given in the service manual in order to aid for our disassembly procedure. And when we are removing ICs, especially, we must use specific tool, like in this one, the IC chip removal tool, because IC chips have very very thin connecting legs. If we try to remove manually with our fingers, we may damage those. So having proper tools is very important, like this specific one. And when we are trying to remove any bigger component like this one, this is a power transformer. It has many cables, like 1 2 3 4 on this side and 3 on the other side. It has at least 7 cables running out of it. So when we are disconnecting such type of component, then we may lose the memory of the connections, the way it was connected in the circuit. So the safe way is to, when we disconnect these, we should label, tag the leads on the circuit with the terminal numbers which were on this on the power transformer, so that when we reconnect, we know that which wire should be connected to which cable or which lead on the circuit. So this is a suggestion when the component is being replaced. While removing the previous ones, all the leads on the circuit, not on this one but on the circuit, also can be leads can be numbered here and then numbered on the circuit board also, so that when we are inserting a new component, we connect it the right way. Okay, once we have replaced the components, okay, before going into this, we must consider that all the components which we are replacing are absolutely necessary to replace. We should not try to replace the components which are working fine, so we should leave them there, because if we are trying to replace the fine ones also, the procedure of disassembly and reinserting the components may cause damage to the soldering components, and also the circuit board itself. It may loosen some connections, and resoldering may causes some issues in the circuit. So if it is working fine, there is absolutely no need to replace the component. Okay, and there's some components like this power transistor the power transformer, if it is faulty, do not try to repair it, just replace it. And there are some switches in the circuit board, if they are damaged, you just need to replace them, do not try to repair them. Okay, once we have replaced the components, then the last step is to check its performance. So in order to check the performance, there are 3 steps included. First is check, then adjust, and then see the interaction. So the check is actually the performance parameter limits, which are given in the service manual, that when we have to check for certain performance parameters. If their values are within the limits which are stated in the service manual, like how much current and what type of output signal, and how much should be the amplification. If all those are within the stated limits, our equipment is working fine, then there is no need to do anything else. If it is not, then we need to make some adjustments or repairing as suggested by the service manual. So we assume that we need some adjustment, so the adjustment will be suggested from the we will get advice from the service manual. We'll see what means what is the our values of the performance parameters, and we see corresponding adjustments which are suggested in the service manual. So those adjustments will be made, okay, in the next step. So according to the check test as described in the service manual, so what type of adjustments are suggested in the service manual, those will be done, and the check will performed again. So if if then the limits of the performance parameters, the values of the performance parameters are in the stated limits, then we are fine. If they are still not, then we need to make more adjustments until or unless we get all the performance parameter values within the stated limits, okay. And then there is an interaction. It will be mentioned in the service manual that when certain type of adjustments are made, then those adjustments will have certain type of interactions with other parts of the circuits. Like it points out that what adjustment described the previous instruction interacts with what other circuit adjustments. Okay, so if we have made some adjustments, how does it interact with other circuit adjustments? So and the nature of this interaction is generally indicated in the service manual, so it is not difficult. Mostly our check and adjustment parts are enough, then we just need to see the interaction which are being taking place as a result of the adjustments that we have made in the previous step, okay. Okay, we have seen until now that if we have certain types of if we have located the fault, then what are the steps we have to follow. We need to after locating after locating the fault and identifying the faulty component, we have to arrange for the replacement part. Once we have when we have arranged the replacement components, then we have to do the component replacement. After component replacement, we have to make a performance check whether our equipment is working fine with the replacement that we have made or not, okay. So that was the whole procedure. But there are some situations when we should not we should decide not to go for repairing, we should just go for replacement. These include serious physical damage to the equipment. Like for example, it has been broken, cannot be fixed, like the glass on the phone. It cannot be repaired, it needs to be replaced, okay. So we cannot just this type of damage cannot be repaired. Or the faulty design or manufacturing faults, these types of faults result in reoccurring problems. So these reoccurring problems cannot be solved because those are the result of the faulty design or the manufacturing faults. So in that case, we should not go for repairs. Those will keep on happening. So instead, we should just replace the faulty component if it is there, or if the device is faulty, there is a manufacturing fault in there, so we'll have to bear that. And if the service information is not available, if service information is not available, you do not know how to repair the device. So instead of just taking it on your own and start to repair it, thinking that you have the technical expertise without the knowledge of the service information, you should not do that. You may be able to do it, but the chances are low. The chances are high that you will further damage or cause multiple other faults while trying to repairing it. Okay, when the devices or the components have been damaged by the fire or they have been water damage, so in such cases you should not try to repair it. You should the attempts to repair should not be made, because the better option is just to replace that. If a circuit board or a component has been water damaged or damaged by fire or smoke, we should just replace that. We should just replace the whole section of those components. The attempt of repair may not be very useful. Okay, the if that specific components have been attempted to repair multiple times, and still we are facing some problems and issues in that. Sometimes it happens that some repairing attempts are made, but after repairing we start to see or experience undefined or means unidentified problems which are not seen before. It means that the repairing attempt was unsuccessful. So if it has happened before, there have been multiple repair attempts, but none of these remain successful, and we are still seeing some failure issues in the device. So it would be better we do not attempt repair again, and we just replace it. We look for other options like replacing the equipment if it is under warranty, or sell that, buy a different one, just don't use that. Because repairing may not be successful next time also. And you should not attempt to repair if proper test and repair equipment is not available with you. If you do not have proper test equipment, means that you cannot make proper testing of the components. You cannot see which one means how much voltage is where, and which component working fine, which joint is okay, and which wiring is fine. You cannot make that make those tests. And if you have those proper testing equipment, you have tested it fine, but you do not have proper repair equipment, you should not attempt a repair, because if you do so, instead of repairing, you may cause some more faults. You can cause further damages, because the components are sensitive. They are very small in size, and trying to open and fix them with hands without proper tools is may not lead to success, unfortunately. So we should try to contain ourselves to attempt for repair whenever it is necessary and possible. Okay, and at the end there are some general guidelines for troubleshooting uh, electronic components. So first, check your test equipment regularly, which you will need to test the equipment and the components. You must keep that nice and tidy and the working condition. And then never trust brand new components to be always good. While you are replacing old ones with new ones, and you think that the new ones are fine, but they are not working fine, you don't try to look for other components which you think have gone bad, but the new components may also be faulty. So you should not trust that brand new components will always be fine, and never assume that there can be only one failure causing a certain problem. There can be other more than one failures which are causing a certain problem. So if you have found one, doesn't mean that that was the only one. There can be others also. So, and if several problems are occurring at the same time, it does not mean that one is causing the other. Okay, so it might be a coincidence that both of them have happened at the same time, but it is not necessarily that does not necessarily mean that one fault has caused the other fault. Okay, this is called as means they say that you must um, uh, uh, know the difference between causality and coincidence. Causality means that one thing is causing the other thing, and coincidence means that they're independent of each other, but there's a coincidence that they're happening together. uh, okay, and the last one, that this is a suggestion and guidelines, a very good one, that if you have been attempting to troubleshoot an equipment, the troubleshooting was very hard and you have been trying for so long that you are worn out, you must ask someone else for a fresh perspective. They can give you a fresh look and you will be amazed at the results, and it really happens. So if such thing happens, try to find a person, an expert, of course the person who knows, have a little bit of knowledge of the equipment you are working on. Then you can find a solution to that. It happened with me and it really does work. You should consider the last one mostly. Okay students, that was all for today, and I hope you learned a few things in this lecture, and please do not forget to rate the lecture. You must consider this last guideline if such thing happens with you, that you have been trying so hard for so long. Try to find someone who can give you a fresh perspective, and uh, you will really be amazed that you can find a solution with a fresh perspective. uh, and it does work. It happened with me a couple of times. Okay students, that was all for this lecture. Please do not forget to rate it, and I hope you have learned a couple of things in today's lecture. Okay, take good care of yourself and see you again inshallah. Until then, the Hafiz.